This is an equation. N is equal to 42. And this is called an inequality. N is less than 42. They're both mathematical sentences. Here's another inequality. N is greater than 42. And yet another. N is less than or equal to 42. Another way of saying we're looking for numbers 42 or less. And here is N is greater than or equal to 42. And finally, one more inequality. N does not equal 42. For N is equal to 42, that one's pretty straightforward. We put a dot over 42 to show that 42 is our solution set. But for N is less than 42, there are infinite real numbers less than 42. So we put an empty circle around the 42 to show that it's not included, because 42 is not less than itself. But it is our starting point. Any number to the left of 42 is less than 42. So that's how we show it by graphing on a number line. And here's N is greater than 42. For N is less than or equal to 42, we include the 42, so we color in the circle. And here's N is greater than or equal to 42. We put an empty circle over 42 and shade in everything else, for N does not equal 42. And often when we write graphs, we write them in a much shorter way. We assume that the people reading our graphs know that the numbers to the right are greater than 42 and the numbers to the left are less than 42, so we only label the 42 itself. Here's an example. Persons under 13 years of age are not admitted without parent or guardian. So we start with the 13. Since it's under 13, we put an empty circle and shade in all of the numbers that represent ages less than 13. And then writing it, we could write A for age is less than 13. And it could also be written starting with the 13. 13 is greater than A. And here's another one. We're going to give a 10% discount for senior citizens 55 years of age and over. So there's the graph. The 55 is colored in because it includes people 55 and also people older than 55. Here's how it's written without a graph. A is greater than or equal to 55. And it could also be written 55 is less than or equal to A. And now we'll talk about something called compound inequalities. Some textbooks call it combined inequalities. But I'm going to ask you to think of a number between 1 and 10. And here's how you would graph that. It represents the graph of all of the numbers that are both greater than 1 and less than 10. Or, as I said in the sentence, between 1 and 10. And we can write that as what I call a triple. There are three quantities separated by two inequality symbols. And that's read 1 is less than a number which is less than 10. That could also be written 10 is greater than a number which is greater than 1. And now I'm going to ask you to think of a number from 1 through 10. That includes 1 and 10, so we color in the circles. And then we can write that as shown. 1 is less than or equal to a number which is less than or equal to 10. The other way to write it, 10 is greater than or equal to a number which is greater than or equal to 1. And here's a different kind of example of a compound inequality. We're giving discounts for children 13 and under or senior citizens 65 and over. So we have two separate graphs that share the same number line. But no one can be under 13 or over 65 at the same time. So this is known as an OR problem. We're allowing people that are both young and old to get the discounted ticket prices. You can't write this as a triple. We have to write two separate inequalities separated by the word OR. So this is read, A is less than or equal to 13, or A is greater than or equal to 65. And here's a compound inequality for the speed limits on interstate highways. Regular streets just have a maximum speed limit, but interstate highways also have a minimum speed limit. So in many cases, it's from 45 through 70 as graphed here. And we can write that as a triple. 45 is less than or equal to your speed, which is less than or equal to 70, where S represents the legal speeds for interstate highway. Or we can start with 70 and go 70 is greater than or equal to S, which is greater than or equal to 45. And we can also write an inequality which is expressed in what I call a triple as two separate inequalities separated with the word and as shown here. Or we could write it this way. And that brings us to this concept. For real numbers a and b, if a is greater than b, then it's also true that b is less than a. And let's do one more example. Here are the speeds that are not legal to travel on an interstate highway. And of course, that's a compound inequality that uses the word or. So we write that if your speed is less than 45 or if your speed is greater than 70, it's not a legal speed to be traveling on an interstate highway. Could also be written this way. When graphing inequalities, the open circle means that the related coordinate is not a member of the graphed set. The colored in circle means that the related coordinate is a member of the graphed set. The words and or have very different meanings when used with compound inequalities.